For the first part of our discussion of single-step dimensional analysis, I want to talk about conversion factors. Conversion factors are simply, as it says here, ratios, representing equivalent values of two different units. I also call it an equivalent statement. For instance, examples of equivalent statements would be 12 inches equals 1 foot, or 1,000 milliliters equals 1 liter. And we can set up a ratio that we can use in a dimensional analysis problem, a conversion problem, and we can write it one of two ways. We can say that there are 12 inches in 1 foot, or we can say that there's 1 foot and 12 inches. Now I realize some places have an abbreviation for foot of FT, but in science you'll usually see it as just an F. I'll accept it either way as long as it's an accepted way to represent feet. But those are the two ways that you can show a conversion factor, and depending on whether we're changing from feet to inches or inches to feet will determine which of those two conversion factors we're going to use. But all we're going to do for this first section of the notes is to look at how we get these conversion factors. So based on what I just did here, do the next one yourself real quick. Just pause it and do the next one. So hopefully you did that, and hopefully you came up with the fact that we could write this equivalent statement one of two ways. We could write it as 1,000 milliliters over 1 liter, or we can flip it, 1 liter over 1,000 milliliters. And make sure when you do your worksheet on conversion factors that this is exactly what you do, that you show both conversion factors, and each side of the conversion factor must have a number and a unit. If you don't have those, it's going to cost you points on that worksheet. Now for the next two conversions, we are going to actually need a conversion chart, and you have this in your notes. And we're looking for, on this first one, inches to meters. And if you look at the conversion chart, inches and meters are length values. So you're going to go to the length section, and I have it marked so that we'll be faster on the notes. I didn't want to spend time looking for the conversion factor. But there, virtually everything that you're going to need for your worksheet is going to be on either this conversion factor page or this one. Please use this one unless you cannot find the units that you need anywhere on this page. So if you'll notice, I have it marked that the relationship between 1 meter and inches is that 1 meter is equal to 39.37 inches. So that's the equivalent statement. 1 meter is equal to 39.37 inches. So with that information, we can now write a conversion factor just like we did before. We simply had to look up the values for this particular one. So 1 meter over 39.37 inches and 39.37 inches over 1 meter. See if you can do the next one yourself real quick by looking up the equivalent statement for quarts and liters on your conversion page, your conversion chart. So hopefully you went to the conversion page and you saw that the relationship between quarts and liters is that there is 1 quart for every 0.946 liters. So 1 quart is equal to 0.946 liters. And that's what you're going to use for your conversion factors. Simply write those as a ratio, 1 quart over 0.946 liters, or 0.946 liters over 1 quart. Now remember what I said about the units. You can only use abbreviations if you use an accepted abbreviation. When in doubt, write it out. If you write out 1 quart and 0.946 liters written out, that is perfectly acceptable. But do not give me a unit abbreviation that is not an accepted one, because I will count points off for that. The last one I want to go over for this first section of the notes is what happens when we have what I call a complex unit. A complex unit has more than one unit in it. And in this case, grams per cubic centimeter happens to be a density unit, and we're going to see more about that in this particular unit that we're studying. But grams per cubic centimeter, when you see a complex unit like that, this division line right here is actually the division line that you're seeing in these conversion factors. And what this says is that 3.26 grams is equal to, and understood, if there's no number with it, it's understood to be a 1, and that 1 has to be there. So make sure you put it in. 1 cubic centimeter. So anytime you see a division sign like that, that you're dealing with a complex unit, that's what it means. You can replace it with an equal sign to write the equivalent statement, and then it is the division line in the actual ratio conversion factor. So 3.26 grams over 1 cubic centimeter, and 1 cubic centimeter over 3.26 grams.